Right, hi guys. Well done for getting your Unit 1 tests done, and I've got the marks back for you today. I will try and get you the mark schemes as well so you can have a look at the answers to the questions that you got wrong. But in the meantime, I really wanted to try and get you to have a look at your Unit 2 work. We don't know, like I said, whether or not you're going to have to submit it, so we need to do as much as we can, okay? So we did the resistivity one just before we broke up, and I want to try and get you back into the flow, doing some work on this and submitting it, and then I'll keep commenting. Now, one of the aspects is you're going to have to calculate resistivity, yeah, in terms of the value that you got based on the results that you recorded. So the method was you had a meter rule with constantan wire taped to it. You took a multimeter which recorded the resistance, clipped that on 10 centimeters, 20, 30, 40, 50, 60, 70, 80 or whatever. Okay, and you recorded the resistance. That is shown here. I'll try and be cool with some. How's this going to work? Yes, so here, good. Results. These will be similar to the results you recorded, okay? I've just put in the mean. That's the one you're going to use. You did 3 trials and then calculated a mean. So you got your length here in meters, 0.1, 0.2, 0.3, which is 10 centimeters, 20, 30, 40. And then your mean resistance that you recorded, okay? I'm going to take you through now how you calculate your own value of resistivity, which is in ohm meters. So you can see here we've got our equation. P, resistivity, equals R times A, resistance times area, divided by L, length. Okay, all of these are noted for you here. So let's go through and use some of this mock dummy data that I have created. So here down the bottom, we've also got our diameters that we measured. Okay, so you measured those with your screw micrometer gauge, and you got those in millimeters. Okay, we've got our length here in meters, we've got our diameter here in millimeters. We need to convert the millimeters, okay, to meters, because our resistivity is measured in ohm meters. So that's the unit we need. So we take our diameter, we convert it. How do we do that? We go, right, this is this value, divide by 10 to turn it into centimeters, and another 100 to turn it into meters. So in total, 1,000. Okay, so that's our diameter. Then how do we calculate the area of a circle? Well, that's pi r squared. Okay, so let's calculate our radius first. Radius equals half of that. Okay, half of the diameter. Yeah, the radius of a circle, halfway from the middle to the edge. Then we're going to square that. So we're going to do equals that one multiplied by itself, the radius squared in meters, and then the area, we're going to take that. We're not going to be particularly scientific because I don't know how to do it on Google, but you can actually use pi. You could do this all in your calculator, your scientific calculator. You don't have to use a spreadsheet. And you can do this equals r squared multiplied by, I'm just going to do 3.14 for pi. So there we go. We've got our area in meters, a very small number. We come up here. We've got our resistance. Let's choose one. Shall we choose this one here? 5.14. Yeah, this is our resistance at this length. Okay, so if we plug the numbers in, we can go right. Equals bracket r times a. So we're going to go r 5.14 multiplied by a, our area down here, and then divide by L. Well, what was the length at that with that resistance? 0.4. So we click that on. That didn't quite do it correctly. Nope, it clicked off it. So here I'll add in divide by 0.4. There. Calculate. Aha, great. So what we can then do is up here at the top, we've got our expected result. I looked this up. This is what you need to do. You need to go to a website, search up what you expect, what the industry value, standard value is for constant and wire. And we're expecting to get 4.9 times 10 to the minus 7. That should say not meters, that should say ohm meters. Ohm meters. Okay, let's have a look at our result. So our result there, if we move and put this in standard form, we would convert that to, I make it 4.88 times 10 to the minus 7. So not a bad result. Okay, so this is what you would need to do. Calculate your resistivity. You don't need to do it for every length, okay? But what you might want to do is do it for a couple, yeah, or you might want to do it for all of them, and then pick the one that's closest, or a couple, and do an average. Okay, the skill is showing the examiner what they want to see is they want to see that you can do these steps, do these calculations, and then come up with and compare your result, yeah, to an industry standard one. All right. I hope this helps, and I hope you can have a crack at this and get your own results for your write-up. Okay. I was going to say see you soon, but possibly not. Stay safe.